Hello everyone. Start from this video. We're going to talk about machine controls with PLC step logic. So we're going to design some of the industry machines like this drill station with PLC. So as you can see, machine like this involved with some of the steps or sequence, right? For example, in order to process the part, the clamp has to close first, then the drill come down, and then after finish the part, the drill go back to the top, then clamp open, right? So that's some steps, or you can call sequence, get involved in this sort of design. All right, let's look at the next slide. So over here on this picture, on this figure, I get from this book online. All right. So on this chart, they also summarize some of the common techniques to solve the sequential problems. As you can see, if we follow this, right? So there's one type of the method is called sequence bit. I already had a YouTube playlist focus on this type of method called sequence bits. And in this start from this video, I'm going to talk about some of the with the other method called step logic. Not necessarily the same as also mentioned over here. So because I don't use flowchart, but flowchart is also a very good way to design. All right, so that's this part. All right, later on, we may have some video to create to talk about the state. We use the state diagram, or there's one I plan maybe on this one. It's called the sequential function chart. Some method like that. All right. So so in order to introduce the step logic, I first I'd like to show you a very simple example to let you to understand what kind of step I'm talking about. All right. So over here I'm showing you the two circuits, very simple circuit. All right. So this is from the Festo trainer. So I basically wired two buttons to control two different lights. All right. So as you can see here, this is the power supply, 24 volt. The blue cable is the 0 volt. So I get 24 into this button, right? So that's normally open, and then go across the button, connect to a light bulb. The light bulb actually is just behind this button cap, right? It's inside there. Right? Then from there, connect to the 0 volt. And same thing for the other button, but the other button is different. Notice here there's a symbol over here. This symbol represents this button. It's not this one. The top one is called momentary. The lower one is called maintain or detent or large, right? So it's just they operate in a different way, right? So but the connection is the same. All right. So let's just look at the video first. All right. So you can see connection, then I press the button. So when I press the button, the light bulb get the 24 volt, right? So you can see it's on, right? So I have to hold the button in order to keep the light bulb on, right? Because it is a maintained push button. Right. Now this one I'm trying to use the maintain button, right? So you can see they behave differently. Right. So with maintain button, I don't have to hold the button with my finger. It's just continue connected, just like the we use at home, right? The light switch, right? But maintain is different, right? So this is what I'm showing you here as the very simple example. With the circuit control, right? So so over here, let's look at this diagram on on those circuit. So that's the one I just showed you with two circuits, right? So you can see that's the symbol to represent the maintain push button to control the light. And then over here, this symbol over here represent the maintain, right? So they behave differently. You see the result. So right now the challenge is that if we want to use this button, which is momentary, and do the same thing, exactly the same thing as the maintain, how do we do that? Right, so that's a challenge that involved with steps. So if you look at the operation, we press the button, then we release, and then we press second time, we can release, right? Something like that, right? So that involve different steps, right? So or sequence, right? So that's why if we want to use momentary button to implement the circuit to do exactly the same thing as maintain, we could. So that's the solution out here. So the key for this solution is that we introduce relays, right? So relay is the logic process device in the electrical circuit. So right now I'm not talking about PLC yet, so we just talk about electrical control. So at this design shows over here, we introduce 4 control relays, CR1 to CR4. Right, and then we have a button to connect to control the PL at the end over here. So that's the PL we will control exactly the same way as the maintain push button. Alright, so I'm not going to go through the electrical circuit details. Hopefully you already learned some of the design. You understand this is a 3-wire control seal-in, right? So with the for example, we first use the normally closed contact from the CR4, and also start with a push button, the normally open contact, right? So notice here on the run 103, we also connect to the normally closed contact from this button, right? So we need to use both type of the contact because as you can see on the on here, right? So it's pretty blur. Sorry. It also have the normally open or normally closed contact. In the moment I'm going to show you. All right. So notice on here, this is a relatively complicated circuit because we have 4 different control relays. We have from 1 to 108 different runs, and on each relay you can see here on the right hand side, that's the cross reference. So for this CR1, we use the contact from this relay in 3 different runs. 102, which is here, 103 is here, CR1-2, and 108 is here, CR1-3. So that means we're going to use 3 different contacts, 3 sets of contact from CR1. Right? Then we have the same thing, CR2, right? So that's basically the design pattern on here, right? So again, I don't want to spend too much time to talk about the circuit. All right, so if you want to know detail, probably you have to watch the other video to understand that. But for now, I'm going to show you the circuit operation of this design. All right, so let me drag this into here. All right. Yeah, so you can see here, that's the same. Yeah, so hopefully you can hear the voice from the video. All right, so first impression, you can see here, this is a huge circuit, lots of wires, right? So lots of wires go around, and I still have the maintain button connected, right? Even behind those cable, you can see I just press the button. That's the target, that's the result we want to get, but we want to use this button, momentary button, right? So on the module right beside it, we have 2 relay modules. So each module has 3 relays. So I use all these 3 relays. You can see all these modules, all the 3 relays are being used. We also use the actual one from the module next of it, right? 4 of the relays. So when I press the button, I want you to focus on those are the symbols to represent the coil of the relay, right? So then there's an indicator light right beside the symbol of the coil, so you can see if the coil is energized or not. Right now they are all de-energized, right? So let me just play the video. So with momentary button, when I first press, so you can see when I first press and holding the button, the first relay is energized. You can see that the light turn on here, right? So when I release, when I press the so you can see the relay 4 is very quickly. All right, okay. Maybe I should replay the video. Let you to see that, right? So in this way, you can see even though the button is momentary button, I can do exactly the same way as the maintain button. Not exactly the same, right? But when I press, the light turn on and it stays on, right? Until I press the second time. But if I press the third time, it will back on and stay on, right? Let's look at the video. Okay, so let me maybe I should explain that little bit in order for us to move on, because that's gonna be the same type of control with PLC. So as you can see here, we use relays to register these different steps. So basically, CR1 indicate to register the step 1, which is when I first time press the button. And then CR2 as the register for when I release the button for the first time. And then second time when I press, CR3 will register it's being pressed again, right? So basically they follow this almost the same design pattern, right? So we use a button as a trigger, and then previous step. So CR1 previous step is step 4. So that's why it's a special. We use normally close. Otherwise, we won't be able to start the sequence, right? Once we start the sequence, CR1 started. It seal in bypass here, but also use a different set to start CR2, right? So you can see here, this is normally closed contact. So before we press, even though this is closed, but this one is open, so you won't be able to energize step 2, right? It's just waiting for step 1. So once step 1 is being energized, because the button is being pressed, right? It's closed on here, it will be open on here. So that will not go to the step 2 right away. It's just waiting for you to release the button. Once you release the button, this become closed, and then you go into the step 2. So when you press for the second time, this will be closed, and because you already have step 2 established, that will go into step 3. Right? So once you have step 3, if you release the button, that's closed, then you have the CR4 energized. Once CR4 energized, remember we use the normally closed contact as a trigger for step 1. So once this relay energized, this will become open, and that will de-energize CR1, and in turn will de-energize CR2, and in turn de-energize CR3. So that basically is a reset, right? Clear all the 3 relays being de-energized, right? So in this way, we can have this 4 steps as a circle, as a like a cycle through, right? And then we find out when we start on step 1, but before step 3, that's the sequence we have. And during those time, we want to energize pilot line. So that's why we wire the circuit in this way. All right. So okay, I think I'm going to stop this video for now. Next video, I'm going to talk about how do we use PLC to do the same thing. Basically, we convert this circuit the one I just explained, this whole circuit into PLC solution. Alright, see you on the next video.